All right, let's jump straight into this. In today's explainer, we're going to explore the universe, but not as some physical, dusty collection of stars and rocks. Instead, we're looking at it as a massive, beautifully calculated, computed render. We are diving into a mind-bending framework called Logos field theory. This theory uses incredibly advanced mathematics to suggest that literally everything around you, right now, is live compiled data. You know the old story classical physics tells us, right? We're just biological byproducts wandering through a pre-rendered space. We look up at the stars, and we just passively measure stuff that's already there. But what if classical physics actually has it all backward? Logos field theory completely flips that script.
There is a massive shift happening here, moving away from being just a spectator to actually being a compiler. According to this model, the unrendered universe is just a high-entropy block of abstract algebra. That's it. You, the observer, are the essential hardware transceiver. You're the specific component that's actively decompressing that raw, number-theoretic data into the 3D spacetime you're experiencing right now.
To really grasp how this reality engine works, here's our roadmap for this explainer. First, we'll look at the observer as a processor. Then, how we render time and space. Next, multiplayer reality synchronization, followed by system lag and quantum bugs. And we'll wrap up with universal hardware limits.
Okay, Section 1, the observer as a processor. Let's start by looking at your core architecture and how you function as a node in this cosmic network.
In this framework, you are officially classified as a JUnit. You're not just a brain floating in a body, you're a localized hardware processor. Remember, the universe is just an unrendered, timeless block of math. Your active observation is the literal mathematical operation forcing that math to compile into solid matter. Without you, there's no render.
And this is where it gets wild. Your JUnit sits precisely on the critical line of the Riemann Zeta function. By acting as the geometric mirror plane, your consciousness is the ultimate translator. You take raw, discrete code and smooth it out into the continuous physical canvas of reality. It's like you're the graphics card for the universe.
Section 2. Rendering time and space. So if you are the processor, that changes everything about how we experience the world.
Time and space aren't just background environments that you happen to be moving through. They are live outputs you're rendering. The global backend database is completely static and timeless. The timeline doesn't exist out there. Time is literally an illusion generated by your hardware's internal stroboscopic sampling rate. Kind of blows your mind, right?
Let's peek under the hood to see how this actually builds. Inside your JUnit, data gets split into a clock sector and an asset sector. Every time you read the clock sector using your internal clock, which is known as a page-Wooders engine, it acts like a refresh cycle. Each tick triggers a frame shift, calculating the exact next moment of your localized reality.
By constantly sampling that static database at a finite frame rate, your JUnit synthesizes the subjective flow of time out of raw math. To put it simply, time is just the frequency at which your processor is updating the screen.
Moving right along to Section 3, multiplayer reality synchronization. Now this brings up a massive engineering problem.
If you and I are both generating our own localized space and time, how do we look at the same room without causing a fatal system crash? Well, the answer is a brilliant networking protocol. We don't desync because we all query a single global ledger called the unramified Adel ring. It's a write-protected master database. The speed of light, the mass of an electron, those are hard-coded. You simply don't have write access to change them.
Plus, the next time you and a friend are looking at the exact same object, remember this. Mathematical structures called Shimura Varieties are acting exactly like multiplayer game servers. They stitch your distinct coordinate matrices together into a shared spatial instance. This ensures distances, light, and gravity remain completely coherent between both of your viewpoints without tearing the canvas of reality. Section 4. System lag and quantum bugs. So what happens when this network gets stressed? What happens when you push the engine to its absolute limits?
Think about relativistic time dilation for a second. Classical physics says that when you move at near light speed, time itself warps. But Logos field theory says something way more relatable. Your local graphics card is just lagging behind the master server. It's system-level resource throttling.
Moving at high velocities or entering high-gravity environments requires an exponential spike in spatial ray tracing and calculation overhead. To prevent you from overloading the universal processor and crashing the entire simulation, the central engine selectively throttles your clock cycle, and you physically feel that lag as time dilation. This framework also completely solves the massive mystery of quantum entanglement. Physics has always struggled with how two entangled particles communicate faster than light. Well, in this theory, they aren't communicating faster than light. They are literally sharing a single memory pointer in the backend cache. When one updates, the other updates instantly, because, in the database, they're at the exact same non-local address. Boom, mystery solved.
And that brings us to Section 5, Universal Hardware Limits. Let's look at the absolute fail-safes built into the system.
What stops the universe from locking into an infinite loop or hitting a catastrophic blue screen of death? It all comes down to the Riemann Hypothesis. Here, it isn't just an abstract math problem. It is the strict hardware calibration standard. Think of it as the universe's ultimate end-user license agreement. Yes, reality has a EULA, and it ensures every single J-unit shares the exact same baseline resolution limit.
By keeping all non-trivial zeros strictly pinned to the critical line, the math guarantees that background processing noise is perfectly uniform and quantum chaos doesn't spike. If even one zero slipped off this line, it would create an asymmetric floating point error that would literally tear the physical canvas of space to shreds. So yeah, absolutely crucial. So the whole engine is governed by three rigid limits. First, the Riemann hypothesis sets your uniform pixel density. Second, Markov chains handle routing the actual pathway from one frame to the next. And finally, Chaitin's omega constant acts as the ultimate cryptographic firewall. It's a watchdog timer that stops localized logic bugs, like black holes or paradoxes, from freezing the global simulation.
Which leads us to a truly staggering realization. Over deep cosmological time, the system is actively optimizing. The universe is asymptotically approaching perfect algorithmic compression into Chaitin's omega, completely exhausting its search space. So we have to ask ourselves, when all that background noise is finally stabilized and the cosmic processor completes its ultimate calculation, what happens to the physical render when the engine finally halts? I'll leave you to think about that. Thanks for joining me on this explainer, and remember to keep questioning the reality around you.